today I'm presenting on Hakon. So Hakon was actually founded in 2016 with the first outlet in Portland Village, and after that they expanded to 300 at Somerset, one Raffles Place, and finally one came to have been renamed to be Kinex today. So what Hakon specialized in is actually custom salad bowls that actually appeal to the calorie conscious that are providing unique and healthy food to them. Also, their environment is warm and friendly to allow them to have a better eating environment. However, to improve efficiency, the main ingredients are actually cooked at a central kitchen before being delivered in a single shift to the multiple outlets around Singapore. So what we did is that we went to do a data collection during the lunchtime from 11:30 to 12:30 p.m. This actually helped us to understand how often customers visit Hakon, as well as the experienced queue time and the expected queue time customers have in mind. Additionally, we want to find out what are the areas that we can improve on and what satisfies customers as well. So next, from our survey results, we have found that 73% spend 5 to 15 minutes in the queue, with 80% not willing to spend more than 10 minutes waiting. Therefore, due to long queues, customers can actually leave the queue if they're tired of waiting, or upon seeing the long queue, they will not even join the queue in the first place. This is understandable, as most of the outlets are in central business district areas, serving to office workers, which are pressed for time. Moving on from the survey, we found that the most popular is actually the salad bowl, with 67% of them, 67% that's being ordered the same as the previous week. Also, a low percentage, 7%, have actually experienced stock out, where what they wanted wasn't available at the store itself when they went to visit. So from that, the implications is that Singaporeans want to see more value for money, which is understandable because most Singaporeans are bargain hunters. And also, increase in service speed, which means that there may be efficiencies or bottlenecks in the outlets themselves. So moving on, there's a need for us to improve the service speed at outlets, as well as to introduce the demand forecasting methods to allow us to reduce wastage due to the high overage cost, as there's no salvage values in the ingredients that were not used on the same day itself. Therefore, by understanding consumer tastes and preferences, we can actually come up with a model to actually allow us to predict demand and rather than to rely on the outlet's estimates, so that this will reduce the lower wastage. As a result of lower wastage, we actually save on costs. For the profit side, if we were to increase the efficiency of the outlets, this will allow us to serve a greater number of customers and therefore increase our profits. So moving on, our other goals actually to improve our customer satisfaction, as most of our customers are return customers, making up 93% of them. So, we can also want to increase customer loyalty and even expand our customer base to other customers as well. Now I'll pass my time on to Commissioner.
So for the first problem, it's resource wastage and utilization. So for our salad bowl, we have many fresh ingredients like avocado, salmon, vegetables, and fruit. And all these are perishable ingredients, and once kept beyond their freshness period, it had to be thrown away, and this gives rise to wastage. So this could have been a potential inventory of other outlets, and there are unambiguous, unfollowed shelf life, which leads to uncertainty whether it's good fit for consumption. So on a daily basis at every outlet, human food testing are done, but the immediate negative health effect does not set in immediately. And this is a loophole in the current procedure. And all these ingredients you see here, they are actually flown from overseas suppliers. So the real lead time is impossible in the real world. And due to demand durability, we have to match the demand to supply for every outlet. And any over-ordering will lead to unnecessary inventory build-up. And once perished, right, all this will have no service value at all. So based on industry standards, our third solution is to find the optimal order quantity. And based on industry standards for a profitable company, it's around 28 to 85%. So we take an average to be 31.5% for the COGS. But since Hakon is currently not so profitable, we assume the cost of goods sold to be on the higher end of 32.2%. So using actual sales across 4 outlets, the sales across 4 outlets amounted to 14K, and we used 33.33% to get the cost of goods sold to be 4.6K. So for the mean forecasted demand, we took 4 weeks using week 8 to week 11. The total demand for the 4 outlets amounted to 28K, and the mean for 4 outlets for that one for per week wise for per month wise is 7,088. So from there we get the standard deviation. We use the forecasted demand for week 10, which is like the highest percentile with respect to the mean. We get a deviation of 1.267, and our standard deviation amount is 89.81. So to calculate the overage cost, we use the price of one salad bowl, which is $14, and we use the 33.50% from the previous cost of goods sold to calculate. And since there's no salvage value for expired ingredients, there's no further reduction. And for the underage cost, we take the selling price minus the overage cost to get the price of underage cost. And from there, we get the typical ratio, which is like the area. So after we punch in all these values into a calculator, we get the optimal ordering quality to be 7127. Next, I'll pass on my time to Karim for the second problem.
Okay. So on their daily basis, every morning a delivery man will deliver the quantity of ingredients required for the daily business. So how is this quantity decided? It's actually solely based on the chef's estimation, which is clearly not very accurate, which will increase the chances of overage and underage costs. At the same time, delivery is made only once a day. So this means that the cooked ingredient is kept in the outlet throughout the day. This questions the freshness that Hakon promises to provide for their consumers. At the same time, the flow time of the ingredients will be higher, and since flow time and inventory costs are positively correlated, this would lead to an increase in inventory costs. So to resolve this issue, our group has came up with a forecasting system that will predict the amount of ingredients to be distributed to the different outlets. For a start, the central kitchen could regularly collect data on number 1, the amount of ingredients left at the end of the day, and number 2, the number of salad bowls sold on the same day. Afterwards, exponential smoothing can be carried out with an alpha value of 0.8. In our calculations, we did not include trend adjustments because the demand seems to be relatively constant every same day. So this is the formula that we're using to forecast the demand. Where, for example, if we want to calculate week 2's Monday forecasted demand, our YT plus 1 would be week 2's Monday, and our YT would be week 1's Monday. So we are using the same day to calculate the forecast for the same day. This is just a representation of how our forecasting system would look like. Okay, the reason why we are using an alpha value of 0.8 is because this gives emphasis on the more recent observations, which is important due to the high liquidity in our demand. Our demand can fluctuate at any time, so a higher alpha value is more suitable in this case. Moving on, the forecasting system can be done easily using Excel spreadsheet, so the company will not incur additional costs in specialized training for this process. Lastly, this forecasting system distributes a more suitable amount of ingredients to the outlets because this is backed by statistics instead of just the chef's estimation. This will lead to lower chance of overage and underage cost, and then lead to a lesser amount of wastage. To resolve the issue of the freshness, we would like to propose that Hakon have 2 delivery shifts instead of 1, where the first delivery will be done as per usual using the demand forecasting system, and then for the second delivery it will be done in the case where there is not enough ingredients. This would allow the chefs to order from the central kitchen slightly lesser because there's a leeway, so this will reduce the chances of wastage. Moving on, the flow time of the ingredients will be lesser, and this will ensure the freshness especially for the dinner crowd. Yeah, now I'll pass on the time to Sophie who will be talking about the third problem.
Okay. So we're talking about the third problem, which is the long queue time. So we found that customers experience long queue time mainly during the lunch and dinner crowd. And this is due to the sudden increase in the number of customers, which leads to the increase in the inter-arrival time. And this causes the formation of a queue, which constantly gets longer as customers arrive, resulting in abandonment and because customers are tired of waiting. So this is our on-site data collection table. So from the results, we made a few assumptions for our process analysis, which is that in-store customers will order 1 bowl of salad and 1 drink, while delivery customers will order 1 salad bowl. And from this, we got our process flow diagram, which shows that firstly, the customer will queue up to get their orders taken. Then employee E will receive the orders, and once the orders are being processed, employee B and C will make the orders. For example, employee B will make the food orders like the salad using the microwave and the toaster, while employee D will prepare the drinks simultaneously. So once the food is ready, employee A will notify the customer for self-collection. So next, we'll analyze the process capacity. So during daily operations, there are 6 resources identified, which is employer A, B, C, microwave, toaster, and blender. Thus, to find out the bottleneck resource, we have calculated the process capacity. So after deriving the process capacity, we found that the bottleneck resource for most of the preparation of dishes to be the microwave and blender. Next, we analyze the arrival process. We calculated the customer arrival rate based on the data collection, which is considered to be the demand rate. And also the customer inter-arrival time is calculated based on the time taken on ordering food between each customers. And also the average customer arrival rate is derived by 1 divided by the inter-arrival time. So we found that the average customer inter-arrival time will be 6.14 minutes. Demand rate is 0.56 orders per minute, and the average flow time is 15.01 minutes. So this is we got the weighted process capacity, which is derived by the product of the proportion of the total number of orders and the process capacity. Therefore, we can conclude that during peak hours, queues are formed due to the high customer arrival rate, which outweighs the process capacity of the resources, as the demand rate is of 0.56 orders per minute is greater than the overall weighted average process capacity of 0.42. So this means that the rate at which the resources can produce each dish is lower than the rate of arrival. Since the demand is higher than the supply, Hakon is capacity constrained during peak hours. Next, I'll pass my time to Samuel who will be talking about the solutions.
Thank you, Sophie. So to solve long queue times, we will need to improve the capacity bottlenecks. So we have identified the microwave as one of the bottlenecks in the process. So this is one of the main contributors to long waiting times. So to reduce flow time, we suggest a simple yet effective fix of increasing an additional microwave, which will improve the capacity bottleneck. So next, moving on to evaluation, we conducted our survey at a single outlet in Somerset, and we assumed that other outlets also experience similar issues, which might not actually be the case. Another limitation is that there will be high cost of implementing our solutions, as shown by we need to purchase new machines, hiring of labor, and this leads to increase of costs. And also this might not necessarily translate to increased profits, and this might ultimately adversely affect the profits of Hakon. So in conclusion, although existing processes put in place by Hakon allows them to function relatively well, we believe that there are still several aspects that can be improved on that Hakon may have overlooked. So the main complaint is long waiting times and ingredient wastage, which diminishes the profits of Hakon. Therefore, our proposed solutions mentioned aim to tackle the shortcomings of the current processes implemented to improve operational efficiency. So assuming that the successful implementation of the proposed solutions, these solutions can be then implemented in future Hakon outlets in its future expansion plans. So with that, I've come to the end of the presentation. Thank you.